So when you go to try to get to gmail.com and your browser realizes it can't get out to the web, it just gets redirected to a local server, which is really running a local copy of Gmail or whatever it may be. That's the local server component. It has a database. This is a full relational client-side database. It uses SQLite as the format, and HTML5 also uses that same format for the database. Just a very simple, really stripped-down relational database, very basic. And then it also has this worker pool, because everything that it does is very JavaScript intensive. You know, we are really moving to a world where JavaScript is really driving everything on the web. And so they have kind of this separate worker pool to handle that so that it doesn't slow things down. So if you've turned on Gears, the way that it actually works is when you first, so you install it. It's a browser plugin. This is not something that's there by default. It's available for a number. I'd say most desktop browsers have a version of Gears available. When you first access a site, you must actually explicitly say, yep, I want Gears to be enabled, because it's going to create a local relational database on your desktop. I kind of like that aspect. Normally, I don't like leaving security decisions up to the end user, but here, you know, we're actually storing data on the client side that I'm sure most users wouldn't have any idea that that was happening. So I kind of like the fact that it lets you know that that's happening. And then the database that it creates, SQLite's really simple. All it really creates is just one file on your desktop, and it's always in the same location. I think the next slide actually, show the locations. And it's just this binary file format, but again, a lot of the stuff is in text, and there's many readers out there. I forget the name of the one I usually use. I think it's called just SQLite Database Browser is actually, I think, the name, just a SourceForge project. So it's an easy way to open up a SQLite database file and actually see it in a user-friendly format, and you can run queries against it. Standard relational database stuff, so you know all the SQL statements that you're familiar with you can use here. But of note, it stores these files in both. It's dependent upon both the OS and the browser that you're using. So it will store it in different places regardless. And that's just important that, you know, if somebody wanted to conduct an attack to pull that file, it is always in a predictable location, but based on both the browser and the OS. Yeah, by the way, if you have friends that do this to you, they're not actually your friends. So. So let's talk about client-side SQL injection. So we've always thought of SQL injection as a server-side attack. You know, the relational database sits on a server somewhere, and if that web application is vulnerable, now I can actually query that database. I can read to it, I can write from, or I can write to it, I can read from it. We've always thought of that as a server-side attack. Well, now we have a relational database that actually sits on the client side. So this opens up a whole new world of possibilities. I mean, can we conduct client-side SQL injection? Well, the answer is yes, but let's kind of talk through it. So the way Gears works is that it's JavaScript driven. So in my web page, I call a JavaScript library and then, you know, send my JavaScript functions to either create a database or read from an existing database or write to it. And you know, so long as it's there, then my browser is physically querying this database that's on the client side. Everything is driven by JavaScript. So if I had the ability to get JavaScript into the page that you were going to, then yes, that's how I could conduct client-side SQL injection. And what's really important about that is that, hey, obviously cross-site scripting, very prevalent vulnerability. A lot of sites have it. So if they have that vulnerability, now I can actually query from a client-side database. I don't need a vulnerability per se in the actual SQL statement and the way it was written, the way traditional SQL injection would work. You could have done all of that stuff in a very secure fashion, but simply because, you know, you've implemented an otherwise secure technology on an insecure platform, then I can attack you. And everything that I'm saying about Gears will also apply to HTML5 because it's a very similar setup. It uses SQLite as the back end. It's all JavaScript driven as well. We'll talk about HTML5 in a second. So just one thing, when I did this, I thought, people are going to say it's a theoretical attack. So I said, well, how hard can it possibly be to go find a site that's using Google Gears and also has cross-site scripting? Surprise, surprise, not very hard at all. It took maybe 30 minutes. So here's one site that I found, and I used them as, to talk about it because they were fantastic. I really want to take my hat off to them because I told them about it, they fixed it right away, and they were even kind enough to give me a year of free service. So good for them. Because I'm sure many of you have been in that situation where you go to report a vulnerability to someone and they just, make your life hell and tell you they're going to sue you and all kinds of things. These guys said, thanks, really appreciate that. So, I'm talking about a vulnerability that they had, but I just want to go out of my way to say that not only did they fix it and fix it very quickly, they handled it in a very professional manner. So they had what was Paymo.biz, or is, it's actually still around, it's basically a time tracking web application. So your guys are out in the field working, you do consulting work, so you bill your clients by the hour, and this allows them to keep track of their time. So Gears makes a lot of sense for them because, hey, somebody's out in the field, they may not have internet access. So they used Gears to offline enable their web application. So I found that they were vulnerable to cross-site scripting. And so this is just to let you know what would need to be injected to kind of walk you through it. So in this case, just because of where the vulnerability was, I had to close off that paragraph tag. That's not standard. That's just specific to that implementation. So Gears is not built into the browser. It is a browser plugin, and so you have to call in the library that it uses, the JavaScript library. So no big deal. Just call that. In this case, I just took it right off the Google site. I have to open the database. And normally when we deal with SQL injection, a big challenge related to the attack is that I have to understand the DB structure. I have to know the names of the tables and the columns and the data types. This is a totally different world. I don't have to guess the database structure using all the tricks that SQL injection typically requires, because if I want to know what the database structure is, I just go visit the page myself. It creates a copy of the database. I know all this stuff. So it's really a lot easier from an attack perspective. So even though it's got that ugly name for the database, I already knew what it was, because all I did was visited the site myself, created the database, I saw that. And then once I've done that, once I've opened the database, it's just standard SQL queries. In this case, I just said, hey, read everything from a particular table. Again, I didn't have to guess the name of that table. I already had that information. And just to show that it worked, I just ended up, in that case, popping it up on my screen. But from an attacker's perspective, it would be very easy to inject that and do something behind the scenes. Let's say, make an image request to your evil server and just have all the data in a GET request so it shows up in your server logs, or email it to yourself, or do something. So you could really do this in attack. Somebody goes through, is browsing their site, and has no idea that they've just been attacked. Meanwhile, you've just taken all of the data that is stored on their client-side database, and you've been able to access it. And it's really, in this particular case that I'm talking about, it's enabled by the fact that cross-site scripting is there. And hey, if you believe some of the stats that are out there, I really like White Hat stats. Their last report, 66% of sites had cross-site scripting vulnerabilities. And these are companies that actually care about security because they're paying White Hat to review things. So I don't think there's too much argument that many sites are still vulnerable to this issue. But what's interesting to me is Google did a really good job of creating a SQL structure that wasn't vulnerable. So if you write your SQL query in the correct way, it's not vulnerable to SQL injection. But because everything's driven by JavaScript, it's the fact that there's a cross-site scripting vulnerability on this that makes it the whole thing vulnerable. So it's this lesson that we've never seemed to learn as an industry, that you can take great technology, but if you put it on an insecure architecture, everything falls apart. It doesn't matter. So just to compare SQL injection and client-side SQL injection, so what are the differences? Well, as mentioned, in traditional SQL injection, a real headache, a real challenge, especially if we're dealing with blind SQL injection, is figuring out that database structure. And so I have to send all these queries to create error messages and get table names and do all these little tricks. I don't have to do that in client-side SQL injection because, again, I just visit the page, creates a database, I'm good to go. SQL injection, that's an online attack because I have to get to the server. In theory, we could actually do an offline attack. A little tricky, but I think that's a neat aspect of it. Because this application will work offline, let's consider a scenario where I send somebody an email, and while they're offline, and that email has the reflected cross-site scripting request in it, and they actually read that while they're offline. Well, because the application will actually still function offline, I could still conduct that attack. Now, I would have to somehow wait for them to go back online before it sends me the information, or maybe I'm doing something where it doesn't require connectivity. I'm just wiping out their database or something. But in theory, we actually could do this offline as well. And last but not least, with traditional SQL injection, it's the actual SQL statement itself that needs to be vulnerable. They've concatenated user-supplied data into that query, and that's why it's vulnerable. Here, it doesn't matter. You can have a perfectly legitimate SQL statement. It can still be vulnerable because it's the cross-site scripting angle. So the victor in my battle here is client-side SQL injection. I think it's a lot easier to do. When I was first talking about this, somebody said to me, well, what's the big deal? If they're vulnerable to cross-site scripting, I could steal their cookie, I could do the exact same damage. And in part, that's a fair statement, but overall, I don't agree with it, because stealing somebody's cookie doesn't necessarily mean you're going to be able to access their log in as them and access the data on the server for a few different reasons. Maybe that site doesn't use cookies for authentication, so getting the cookie isn't going to help you. They may have additional access controls, such as restricting the IP address that the request comes from. But also, there's no rule that says what's stored on the client side in this client-side database has to be the same as what's stored on the server side. In general, I would say it's not. In most of the things that I've seen, it's actually more of a subset of data, but it could be completely different data. So you could be attacking something completely different. So what sites are using Gears? There's many. It's really been driven a lot by Google, because Google has actually enabled a lot of their sites, and obviously they're a trendsetter. Of note, as we move into HTML5, we'll actually see Gears start to go away. So earlier this year, Google said that they're going to wind down support of Google Gears, and that wasn't surprising, because at the very beginning they came out and said, we have no intention of competing with HTML5. We just we're not ready to, we don't want to wait for HTML5, because HTML5, as I'll talk about, it's a spec that's been going on for many years. It's starting to get adopted, and browser vendors are adopting little components of it, but it will be many years before it's fully, the spec's not even done yet. So it'll be many years before all browsers have this stuff. So Gears is really more of a bridge. So not surprising. I think slowly we'll start to see it actually go away, and we'll see Google and others start to focus more on the HTML5 angle of things. Just some of the pros and cons of it. I like the fact that it requires user acceptance and says, hey, I'm going to create this relational database on your machine. They've done a good job of actually creating an implementation of SQL and SQL queries that's not vulnerable. But as mentioned, if this is implemented on an otherwise vulnerable system, doesn't matter. Let's talk about HTML5. So HTML5 getting a lot of buzz right now because a lot of people are saying, hey, this is the Flash killer. I don't totally agree with that. But it's going to bring a lot of changes to the way HTML, to the capabilities of HTML. But one of the things, so HTML5 has tons of stuff. It's a huge specification. They began working on it in 2004, finally got a working draft out in 2008, and it's only starting to be adopted. Some browsers have really adopted very little. Others, like WebKit, has been a little more aggressive. But one slice of it is what's called structured client-side storage. And that's what I'm most interested in, because that's really what's the Gears equivalent. It really has the same functionality. It has a few different storage capabilities. Session storage, you could think of that as just your traditional HTTP session cookies, a little bit more flexibility. Local storage, again, like HTTP cookies, persistent HTTP cookies. The one that I'm most interested in is what they call database storage, because that is, again, that full local relational database capability. SQLite is the spec that they use for that. So from that point on, it's really the same thing as Gears. So the attack that I just talked about using cross-site scripting, will work the same way against HTML5 as it worked with gears. So what's in HTML5, just to give a little background? It has all these structural elements. Today we have div tags to kind of slice and dice up our page and treat things differently. So it really gets a little more granular there. It has very specific structural elements, headers, footers, things of that nature. But what's of more interest to me is all these APIs, cool APIs. Now we can build web applications that are a lot more interactive, do drag and drop. The video is the one that's getting a lot of buzz because now YouTube and Vimeo and all these sites are actually implementing HTML5. And what's doing that? Well, because before Flash kind of controlled the world of video on the web, but now that Apple is being a stick in the mud and saying we're not going to support Flash. So sites like YouTube are saying, okay, well, we'll enable HTML5 because WebKit-based browsers already have the capability to handle certain parts of HTML5, the video being one and the database storage being another. The challenge there is all of the browser vendors can't agree on a spec for the video. We've got Apple saying it's got to be MPEG-4, and then Firefox is upset because MPEG-4 actually isn't license-free, so they want this Ogtheora to be theirs. So anyway, it's a long way to go before we get standardized, but there's going to be all these cool new APIs that will allow you to do a lot more functionality in your web app. But again, the one I'm most interested in is that last one, offline data storage. So people say it's the Flash killer. I don't agree because you can build a very full-featured application using Flash. HTML5 is not designed to do that, but it definitely is going to make a dent, especially in the audio and video. I mean, now adding a video is no different than adding an image tag. Today we have image source, and we just pull an image in. Now, literally, video source, you pull it in. Done. But all of these APIs are driven by JavaScript. So again, this really heightens the value of a cross-site scripting vulnerability because now there's so much more that I can do. Which browsers are supporting that local database storage piece of HTML5? Kind of all over the board. Really, in a nutshell, it's the WebKit-driven browsers. So that's Safari and Chrome primarily. Mobile Safari does it, though, which is really important. So mobile Safari is what's on the iPhone. So if you have an iPhone, take a look. Go into your settings. Go into Safari. Yeah, and under the Safari settings, you can actually see that there's a databases flag. And then click on that. And you'll see, most likely, if you've had your phone for a while, there will be domains listed. So these are all relational databases which exist on your iPhone. SQLite format. You don't know they're there. It's not like Gears where you get a pop-up that says, hey, I'm going to create a relational database. In this case, it just does it behind the scenes. But for every one of these sites that you've been to, there is now actually a database on your phone. And Google has really pushed this. So you can see here, this is accessing Gmail, but I highlighted the airplane icon to show you that this is actually offline. I'm not online at the time that I'm doing this. And they've done this for a lot of their applications. Why? Because whereas for the desktop, they used Gears to enable this offline capability. There is no Gears plugin for the iPhone. They couldn't do that because Apple's got this more closed ecosystem. They don't want people building plugins for their browsers. So they said, hey, cool, no problem. We'll attack that with HTML5 because HTML5 gives us the same capabilities. And WebKit-based browsers already support this capability. Mobile Safari is a WebKit-based browser. And actually, I think that it is the mobile world which is really going to push adoption of this because the mobile world gives us a bit of a clean slate. We don't have all the things that we had. Whereas before we had options like Flash, we had options like Google Gears. Now we don't have those. But HTML5 can do many of those things. So I think we're going to see more adoption of HTML5 capabilities in mobile sites than we will in traditional websites. What are some of the risks associated? So this is the same thing. If I have cross-site scripting, I can still query that same database. In this case, there is no concept of the path attribute. So I can query it regardless of where on the domain this database was actually created. So think of sites that have a lot of user-supplied content. maybe somebody else has created a cross-site scripting vulnerability. Same thing where I don't have to know the database structure, but SQL, just like other relational databases, there are standard queries where if you just want to say, hey, give me every database that's been created, give me every table that's been created, it's got that too. But you actually don't need it because you don't need to guess the database structure. You just go to the site and you get a copy of it. So in addition to using cross-site scripting as an attack vector, if you have the ability to redirect a browser's traffic, you could also use that as an attack vector. So here's just a simple WebKit. So if you want to see HTML5 relational database capabilities in action, just go to webkit.org. They have this neat little example where you have you make these sticky notes, and you go to the site and then go check those storage locations that I showed you in an earlier slide, and you'll see that it's actually created a relational database. And you can open that up in one of the SQLite viewers, and you can actually see what's there. So, but it has this concept of a same origin policy. So if I go to visit this site, it'll create it specifically for that site. This is just one of those SQLite browsers, SQLite Database browser, free SourceForge project. And you can see that traditional database. I just have the structure. I can execute SQL against it. Oh, this is the storage location. Sorry, in this case, I hadn't shown it to you before. So I only showed it for Mac OS X because really today that's really the only platform where you're going to see this on, because it has to be. Well, that's not true because Chrome supports it now. But I didn't actually do this on a Windows machine. But same idea. It will have a standard storage location. So if I wanted to, remember I conducted the SQL injection, client-side SQL injection attack using cross-site scripting for gears. Same thing here. I can, although this is what I would need to inject. It's actually one step easier because in the gears example, I had to call that outside library. I don't have to do that because now it's actually baked into the browser. This is real functionality that is part of the browser, in this case Safari. Same thing. All I have to do is know what database to open. Don't have to guess that. I just go to the page, get that information, and then just execute my SQL. That simple. So if I could inject that content, I could actually read from the client-side database. So how could I do that? We already talked about the concept of using cross-site scripting to do it, but are there other options? Well, yeah, I could use traffic redirection. So all that matters is my browser must believe that it is going to the site that set up the database, and as long as it believes that, it will freely allow it to query that database. So to demonstrate that in a simple fashion, so here I go to the site where this demonstration application is, webkit.org. Make a couple test notes there. And you'll see, that's the URL where it is stored online. All of this is client-side, so I can just copy, literally view source code, grab that source code, set it up on my own browser, and then now you can see, it's the same page running on localhost. But those past notes didn't come up because my browser says, I'm not going to, this isn't the webkit.org database. I got to create a brand new database for localhost. So it had a fresh template. So I created a note there, just say, hey, this was written on localhost. But then, just to show a redirection, I just changed my etc host so that webkit.org will actually get redirected to my local machine. And now when I view the page, sure enough, I'm seeing the original notes that I'd set up that were at webkit.org. So if I could redirect traffic, as long as my browser believes that it's going to the site that originally created the database, and I have the ability to inject JavaScript into that page, now I can query that same database. So I wouldn't necessarily need cross-site scripting as the attack vector. So maybe I do traffic redirection through some kind of DNS hijacking, or I have a browser vulnerability where I actually have the ability to write to the file system, so I just physically alter their etc host file. I definitely see a proxy as a capability to do this. You convince somebody to view the web through a proxy that you're running. You can just inject the JavaScript directly into the stream and conduct your attack that way. Or, as I'd mentioned, cross-site scripting. So what kind of stuff is stored in there? Well, a lot of Google applications are enabled to do this. And if you want to see it in action, obviously it's kind of hard to test on your phone. Because the desktop version of of Google Voice, for example, won't use the HTML5 relational database because they already have gears running for that. But a simple way to test this is just change your user agent. You're on Safari, change your user agent to the iPhone user agent, because that's how it decides what website it's going to deliver up. And then you'll get the iPhone page, and it will actually create the relational database and use the HTML5. So just to show you, these aren't simple databases. There's a lot of stuff stored in there. Here's a view of Google Voice. Here's a view of Gmail. This is all the stuff stored. What is actually in there? All kinds of stuff. If you look at the Gmail relational database, it'll have snippets of all of the emails. It won't have full email messages for everything. It does, however, have full message body for cached messages. So I don't know if there's a number limitation, but there's usually a couple dozen messages that actually have the full message in there. But it'll have email addresses of who the email was sent from and to. So in my opinion, really valuable information if you're an attacker that you could retrieve this. Google Voice, really interesting as well. Because it doesn't store the voice messages, so you're not going to be able to steal those that way. But you can definitely get contact information, name, phone numbers of people, addresses, and even their image. Like if somebody's added their image to their Google account, I thought that one was kind of interesting. It'll store the URL for it, and I'd assume that would be locked down based on, you had to be logged in. So if I stole that URL, no. So you could actually even get pictures of all the people that somebody was friends with. So, but why is this different? If I could get in line, I could already sniff your email. As I'm sure that this weekend many people have had their email sniffed, right? Because they were using an open network. So why is this different? Well, the difference is that this isn't passive. This is active. I don't have to wait for the information that I care about. I can actually query the database. As long as I can get that client-side JavaScript in there, I can write whatever query I want. I can say, give me the whole database. I can say, show me all the person's friends. I can say, show me all the phone numbers of people. So this is actually active querying of the client-side database. And this is functionality. It's not exploitability. When a traditional SQL injection attack, I have to find something that's vulnerable. So I couldn't do that on any site. In this case, if I can inject my JavaScript, it's a functionality. I can query the client-side database. Gears versus HTML5, again, these are not competing technologies. Expect Gears to actually fade away as HTML5 becomes more available. Today the relational database component of HTML5 is really only available to WebKit-based browsers. So that's primarily Safari and Chrome. It's not supported on, I think I actually have, maybe I showed it earlier, but it's not supported on IE, it's not supported on Firefox, not supported on Opera. But once those browsers support this relational database local storage component of HTML5, then I think you'll see Gears disappear once and for all. Just to compare all those different storage technologies, cookies, hey, we've had them forever. The beauty of them is that they're universal, so if we want to use that as a storage mechanism, everyone has them. Real limited, though, 4K of data typically. I can only store text in there. Flash local shared objects, just to review that. It is pretty much universal, thanks to YouTube. Everybody runs Flash. And I have greater storage capabilities, 100K by default, and people typically aren't going to be able to flush that. But the future really lies not so much with Gears, but HTML5, although they're pretty much the same thing from this perspective. Unlimited storage. I mean, there's no restriction on how much you can store there. But it's the adoption that's the big difference. There aren't too many sites and end users that are using this just yet. So how will this change things for an attacker? Well, now we're dealing with active attacks. Again, this isn't passive data sniffing. If I can get my JavaScript in there, either from cross-site scripting or from injecting it through traffic redirection or because you're running through my proxy, I can query that relational database on the client side. The structure is open. I don't have to guess at what the database structure is. Easy to find out. So the attack surface is very different. Before, we had all the data stored on a server somewhere. Everybody's data was there. If it was vulnerable, really bad, because I could get everybody's data. Now I have everybody's data distributed all over the place. So I'm only going to get their data, but in my opinion, actually a lot easier to attack because all I have to do is get my JavaScript in there, and there's a lot of avenues to do that. And just the cross-site scripting angle alone, if 66% of sites have cross-site scripting vulnerabilities somewhere on them, and again, it doesn't matter where the vulnerability is, because as long as the request comes from that domain, I can query that database. There are going to be many sites that are going to be deploying client-side storage that are going to be vulnerable. I have little doubt about that. Another thing that I think we should keep an eye on, because it's an interesting angle for this, is web-based worms. So, you know, we've seen web-based worms. SAMI kind of came onto the spotlight a few years ago. This past year, we had the stock daily worm. So now, though, we have the ability for client-side storage. So we have this persistent storage. A web-based worm, the persistency always occurred on the server side. So like the stock daily worm, it was actually infecting a form field on a user's profile. Well, now part of the persistency could be offline. So, you know, maybe even if the website cleans something up, somebody else comes back online, they actually have that malicious JavaScript stored on their client side. You know, maybe they can push things and use kind of drop boxes. I don't know. It's up to the creativity of the attackers, but definitely gives a new angle there. So just some of my predictions going forward. I think that Gears adoption will die off as HTML5 gets more widely adopted. HTML5 adoption is going to be bigger on sites that are geared toward the mobile market because of some of the limitations of technologies that aren't available on mobile devices like Flash and Gears. Vulnerable sites, we'll continue to see sites pushing the limits of traditional storage technologies, cookies, local shared objects. So we'll see all kinds of interesting things there. But you know, the biggie is that as sites start to adopt Gears, and especially HTML5, I think this whole concept of data leakage or stealing data from this client-side relational database will become a much, much bigger issue. And with that, I thought I'd leave you with something memorable. Fortunately, this guy's not my neighbor. Any questions about things that we talked about? Yeah, go ahead.
Is there any room on the clients to like restrict usage of the database, like based on an SSL or non-SSL site, or is there any room in the spec to enforce that sort of?
So not that I've seen. You know, I certainly haven't read the whole spec, but I've not seen that. As far as I can tell, it's not restricted by path, and it's not restricted by, you know, the transmission medium. Yeah, go ahead.
Just a question. Do you see the usage of cookies changing with this? Like, will the site shift to use local database instead?
Yeah, I do think that cookies are certainly less valuable. Even, like, if you think of... So the question was, sorry, I should repeat that. The question was, are we going to see the usage of cookies change because now there's these other options available? So yeah, and I think we've already seen that. Like, I think many developers are actually using both traditional cookies and Flash cookies. They use both because maybe somebody doesn't have Flash enabled, so I still want to have that traditional cookie. But Flash gives me a great backup. You know, if somebody flushes their cookies, all I have to do is create my page in such a way so that it looks for a regular cookie, doesn't see one. Okay, step 2, look for a Flash cookie, finds that. Oh, okay, rewrite the original cookie, so it doesn't matter if they flushed it. You know, now here's 2 more options for local storage. So yeah, I think you know, cookies are less important because we have these other options. But you know, today we don't have broad enough adoption to just say, hey, I don't need cookies anymore. Yeah, go ahead.
Along similar lines, do you think that the browser developers are going to be clever enough to ensure that, although the HTML spec doesn't require that explicit permission be obtained by a user, do you think the browser developers will build that in anyway, given that privacy is so important to users now?
They certainly could, although, you know, my opinion is, so the question is, explicit permission is not required to create this relational database with HTML5. Gears does do it, not with HTML5. Will the browser vendors make that? In my personal view, I think browser vendors are really against anything that kind of degrades the browsing experience, right? And getting that pop-up does that. And the reason it's okay for Gears is very few sites have Gears, so you get a pop-up couple times a month, big deal. Imagine, I think we're definitely moving to a place where most sites will have relational database storage. That'll be a really common thing, so you'd get pop-ups all over the place. So my guess would be no, they probably wouldn't do that. Yeah, red hair?
It certainly happened with the GeoIP stuff that's been
Yeah, so she mentioned that you are getting that pop-up for like the geolocation stuff. And yeah, good point, Firefox is doing that. But, hey, will they still do that when, 500 sites a day do it? Hard to say. So we don't. And in the end, I mean, that's not really creating better security. It's like Windows Vista failure. It just asks every end user, do you want to install this? Do you want to install this? Believe me, I can't tell you the number of phone calls I got from my mother. Should I click on this link? And I'm like, Mom, just get off the web. It's probably your best bet. Yeah, go ahead.
How long do you think it's going to take for HTML5 to be adopted? And is given all these open questions about security, are they actually going to do something on the security side in terms of
so how long?
Some of these potential obvious things that you're citing.
Yeah. So how long for HTML5 to be adopted, and will they add increased security for these things? So as far as the adoption, I think on the desktop browser, we're actually probably years away because, number one, the HTML5 spec isn't done yet, right? It's still ongoing. Number two, for this particular piece, the relational database piece, IE doesn't support it, Firefox doesn't support it, Opera doesn't support it. So we, at the very least, have to wait for another iteration of browsers. So say that's a year away. And then, people actually have to start adopting it. But I don't think it matters because I think what's really going to drive it are these devices. And today, right now, Android and the iPhone can handle this relational database capability. And the biggest driver, the company that's building the most HTML5 sites, in my opinion, is Google. And hey, I mean, they're a big trendsetter. So I think that the mobile world is becoming so much more important. So how long will it take in the mobile world? I think it's already happening. I think it'll take longer in the desktop world. Oh, and the security piece was the last one. Sorry. We don't learn from our mistakes. We have this fresh start. We can create this thing. And when I first got this, I was like, oh, wow, cool. It has no security whatsoever. All these lessons that we learned on the desktop browser, now we have phishing block lists and malicious URL block lists, and IE has cross-site scripting protection. Nothing on any mobile browsers. We don't learn from our mistakes, but the good news is we're all going to be employed for a very long time. Any other questions? All right, well, I'll stick around for a bit if you just want to chat one-on-one, but thank you very much.